think you have completed question number 16, what we discussed yesterday. So it is better to find that A7 and A minus 1 separately. After finding it separately, simplify. You get a quadratic equation which can be solved. Okay. Now coming to question number 17, page number 186, question number 17. It's a homework, but see that question. Question number 17 is a homework. Question is, a man starts repaying a loan as first installment as 100. A man starts repaying the loan. First installment is 100. Then after every installment, he increases the installment by rupees 5 every month. The question is, what is the amount he paid? What amount will he pay in the 30th installment? What amount will he pay in 30th installment? In all such questions, better first list that sequence. List that sequence means write those numbers. So here, the first installment is 100. First installment is 100. Second installment increased by 5, 105. Third installment 103, etc. It goes. Definitely, seeing these numbers, we can make it out. It's an AP. Whenever AP is known, we can find the first term A and common difference B. So here A is 100, D is 5, A and D are known. Now the question is to find what amount did he pay in the 30th installment. 30th installment. Now the common doubt is it A30 or is it F30? The question is to find the amount paid in the 30th installment. So the amount paid in the 30th installment, will it be A30 or F30? What is it? First one or second one? A30 or S30? I'm getting some answers. Let me see whether. Okay. Yes. Few among you wrote A30. Few of you wrote S30. Such cases, see here, A30 denotes the 30th term. 100, that's the first term. This first term denotes what? Actually, first term denotes what? First term denotes the amount paid in the first month or first installment. The second term, A2. Second term, so this is A1, A2, A3. A2, the second term. Here, second term denotes what? Second term A2 denotes the amount paid in the second installment. Second installment. Third term denotes the amount paid. So this is A3. A3 denotes the amount paid in the third installment. If so, the amount paid in the 30th installment will be A30, not F30. It is A30 because each term denotes the amount paid in that installment. So here the question is to find A30. Whereas, suppose that the question was to find S30. Suppose the question was to find S30. Then what will be the wordings of the question? Think it. What will be the wordings of the question? If it was to find S30, then what should be the wordings of this question? Definitely it will not be the amount paid in the 30th installment. Here it is asked to find the amount paid in the 30th installment. Yes. No, total amount paid in the 30th installment. Total amount paid in the 30th installment means that is A30 only. The amount paid in the 30th installment is A30. My question is, if it is S30, then what should be the wording? Yes, I think Amar, you wrote right. Yes, Amar, you're right. If it is S30, yes, then the question will be the total amount repaid or total amount paid till 30th installment. The total amount paid till 30th. So here, S2, we know some of these two will give the total amount repaid after second installment. In second installment, the total amount repaid. Some of these three means the total amount paid till that. Total amount paid. It is the total amount paid till that. So here the question is, or the total amount repaid. Here the question is not to find total amount repaid. The question is to find the amount paid exactly the 30th installment. So it is year 30. So do it as a homework. Next one, question 18. We'll do it here. Second question again. Question 18. See that question, read the question. We have the interior angles of a polygon. The interior angles of a polygon. The smallest angle is 120. Then each angle differ by 5. That means, and also it is given the smallest angle is 120. So 120 degrees. The next angle will be 125 degrees, 130, etc. This is an AP. Now don't do it now. Wait. Definitely, whenever AP is not, so what are the interior? Okay, right. The interior angles are. The interior angles are 120, 125, 130, etc. Is an AP. So A is 120, B is 5. The interior angles are 120, 125, etc. Is an AP. So A and B are known. First time, man. Now you are asking question number 17. Who asked me question number 17? I don't want to. Yes, one of you asked me, so what about question number 17? What about question number 17? Tell me, what about question number 17? One of you asked me. So this is question number 18. See here, the smallest angle is 120. Okay. Smallest angle is 120, 125, etc. So A is not D is not. See, the interior angles, we know how to find the sum of interior angles. How will you find sum of interior angles of a polygon? Polygon, you know triangle. Angle sum property of triangle is 180. That means sum of interior angles of a triangle is 180. If it's a quadrilateral, quadrilateral means what? Polygon with 4 sides. So a polygon with 4 sides, when I am asking you what is a polygon generally, in the class also, if I am asking you, what is the name of the quadrilateral, no, what is the name of the polygon with 4 sides? What is the name of the polygon with 4 sides? Then at least some among you may answer it as squares or rectangles. Some among you will say polygon with 4 sides is a square. Few others will say polygon with 4 sides is a rectangle. No. Polygons with 4 sides, it's a quadrilateral. So we have quadrilateral, we have pentagon, we have hexagon. Is it? This one. So octagon is. Now, how will you find the angle sum property of a quadrilateral? What is the sum of interior angles of a quadrilateral? Yes, you're all right, 360. How do you get 360? The actual thing is, whenever we get any polygon, we will break that into triangles. how to break into triangles by drawing join using. Now, how many triangles are there? We have 2 triangles. So it will be 2 into 180. For one triangle, it is 180. So sum of 2 triangles will be 2 into 180. Pentagon. Pentagon. If you are making triangles, this one already joined to one vertex. One, you can see we have 3 triangles. So pentagon with 5 sides, it is 3 into 180, is it? Because pentagon we can divide it into 3 triangles. For each triangle, 180. So for 3 triangles, 3 into 180. Hexagon. How many triangles do we get? 1, 2, 1, 2, 3. We have 4 triangles. 4 into 180. It's hexagon. See that? So for any polygon with 4 sides, we can break it as 2 triangles. Polygon with 5 sides, we can break it as 3 triangles. Polygon with 6 sides, we can break it as 4 triangles. If so, polygon with n sides. Polygon with n sides, in all, how many triangles do we get for n sides? N minus 2, right? So n minus 2 triangles means n minus 2 into 180. So sum of interior angles of a triangle, interior angles of any polygon. Sum of interior angles of any polygon is n minus 2 into 180. N minus 2 into 180. Again, we said about polygons. Polygon with 4 sides. You know definition of polygon. Polygon with 4 sides, it is quadrilateral. Polygon with 1, 2, 3, 4. 4 sides. Polygon with 5 sides. 1, 2, 3, 4, 5. Is it a quadrilateral? Is it a quadrilateral? Is it a pentagon? Yes or no? This one, we have 4 sides. So, is it a quadrilateral? Someone said no, someone said yes. Will it be a pentagon? Is it a quadrilateral? The answer is yes, it is a quadrilateral. It is a quadrilateral. It's a quadrilateral. This is a pentagon. But in our study, we don't consider this as polygons. Actually, these are all polygons. These are all polygons. But in our study, what we learned, I think you learned in class 7 or 8 when regarding polygons. You learned it. But the thing is, there is no question based on it in textbook. So even if the sir explains it, you will not listen to it because people have the habit of only drawing from board. Such polygons, there's a special name for the polygons. There's a special name for these polygons. Anyone, do you remember it? These types of polygons, what we study only these types of polygons. These polygons are called, Keshav, regular polygon means with all sides equal, that is square. Square is regular polygon. Equilateral triangle, all sides and angles are equal, that is regular. These polygons are called convex polygons. Convex polygons. These are non-convex. Convex polygons. So in our study, polygons means only, yes, now you are remembering. In our study, polygons means we take only convex polygons. Speciality of convex polygons, the interior angles will be always less than 180. Here you can see this angle is more than 180. This angle is more than 180. These are non-convex. They are not convex polygons. In our study, we have only convex polygons. So remember it. Now, so we know angles are probably, so n minus 2 into 180. So sum of Sn is is sum of interior angles. Sn is n by 2, 2a plus n minus 180 degree. Sum of interior angles n minus 2 into 180 degrees. Write this inside as a note. Sum of interior angles of a polygon n minus 2 into 180. Sum of interior angles of a polygon. When we say polygon, they are all convex polygons only. We consider only convex polygons. Now here, put the values. We know the value of A and B. Substitute the values and cross multiply to n 2 into 120 n minus 1 5 n minus 2 180 into 2 because this 2 cross multiplied. I cross multiplied this 2. This 2 I got from here. This is n 240 5 n minus 5 182 is 360 360 n minus 720. This is n 5n plus 235 is equal to 360n minus 720. Opening bracket 5n square 235n minus 360n plus 720 is 0. Again simplifying 5n square 235 minus 360 35 5 40 20 100 minus 125n quadratic equation. Remember it, whenever we get the coefficient of second degree term, check it whether it is divisible by, yes, this is divisible by 5. N square minus 25n plus 720 divided by 5, 124 4 is equal to 0. Now discriminant is minus, any method, either go for discriminant or factorization as you wish. Minus 25 square minus 4 into 8 144 625 minus 144 fours. 14 fours are 56 56 576 which is 49. Minus p plus or minus 2p by 3 becomes minus p is 25 plus or minus 7 by 2. 25 plus 7 by 2. 25 minus 7 by 2. 25 plus 7, 32 by 2, 16. 25 and 8 by 2, 9. See that we got two values. Yes. In quadratic equation, whenever we get two values, yes. In quadratic equation, whenever we get two values, we have to check whether we can accept both the values. Definitely, n stands for the number of sides of a polygon. Number of sides can never be a fraction or negative. Definitely, if n had been a fraction, we could have rejected it there itself because number of sides can never be a fraction. Even number of sides cannot be negative also. Negative number of sides is not possible. Whereas here we got both positive. Can we accept both? For that, if n is if n is 16, if n is 16, a the last angle, because a here a1, a2, 120, 125, 130, each term denotes the measure of the interior angles. So we'll say the last angle. A plus 15d, 120 plus 15 into 5, 120 plus 75, 195. Interior angle, 195 degrees, that is greater than 180. Therefore, not possible. So, or rejected. Because we have shown that earlier, convex polygons. These are all convex polygons. Polygons in our study, they're all convex polygons. And in convex polygons, the interior angle can never be more than 180. So here, the interior angle we got 195. It's more than 180. It's not possible. So it is rejected. Therefore, number of sides is 9. Number of sides is 9. Let me take, I think I didn't take the reference. Did I take the reference? No. Let me take the reference. The angle cannot be negative. See here, both are positive values. That's it. So that's AP is over. Now we come to the next one, geometric progression. Geometric progression. We call it just GP. Geometric progression. So, AP, the meaning of AP, ABC, for example, 5, 8, even 20, 15. So AP we get by adding a fixed number, whereas 2, 4, 8, 16, or 1, 3, 9, 27, 64, 32, 16, 8. These types of progressions. What's the specialty here? Each time you can see we get by multiplying a fixed number. AP, it was adding a fixed number, whereas for GP, geometric progression, it is multiplication by a fixed number. Here, each time is obtained by multiplying 2, multiplying 3. Here, multiplying 1 by 2. Division by 2 means it is multiplication by 1 by 2. So that is called GP. So write it. GP. GP is a sequence in which GP is a sequence in which all the terms, GP is a sequence in which all the terms in bracket except first term. GP is a sequence in which all the terms except first term is obtained by multiplying a fixed number . fixed number to the previous term. So GP is a sequence where all the terms except the first term is obtained by multiplying a fixed number to the previous term. Next line, the fixed term multiplied. The fixed term multiplied is the common ratio denoted as R, and definitely R is not equal. R cannot be 0 because multiplication by 0 means then everything will be 0. That's not possible. So common ratio, the fixed term multiplied is, or the fixed number multiplied is R, common ratio denoted by R. Therefore, see, first term A, second term multiplied by R. A multiplied with R will give the second term AR. AR again multiplied with R will give AR square. AR square again multiplied with R will give AR here, etc. Is Q. Because in AP we write A plus D, A plus 2D, A plus 3D. We keep on adding 3, D. Here we keep on multiplying R. See here, second term, the exponent is 1. Third term, the exponent is 3, 2. Fourth term, exponent is 3. Therefore, what will be A n? The nth term is A R raised to n minus 1. A n is A R raised to n minus 1. So defines the nth term. The nth term of a GP, we use this formula. Similarly, to find sum of n terms, here also we use two formulas. A into 1 minus R raised to n by 1 minus R. We use this if R is less than 1, or it can be A into R raised to n minus 1 by R minus 1 if R is greater than 1. This is formula for SN. Derivation no need. Derivation just keep on know. A derivation AN. First time A, second time AR. Just by observing. Third time AR square, etc. Keep on doing it. So remember the formulas. AN stand for the nth term. Sn, we have two formulas. Of these two formulas, whichever you use, you get the answer. But if R is less than 1, using this is better. Even if you are using this one, we get the answer. It's a different thing. Why this is better? If R is less than 1, 1 minus a number less than 1 remains as positive. So denominator will be always positive. Here, if R is more than 1, R minus 1 is positive. That's why we use this one. Yes, so question we have two, so 2 minutes earlier, 3 minutes earlier. Today's class we stopped 3 minutes earlier. Yes, 3 minutes earlier. So next day, even if I